Here we have f of x, which is x plus 3 all over 2, and g of x, which is 5 over x. And let's find the composite function f of g of x and its domain. Okay, so here we see that g is the inner function, okay, and f is the outer function. Okay, so let's write the f function first. This is f of x. You notice I didn't put an x here, right? I put a parentheses. So what should we put in the place of the parentheses? We should put g of x, right, which is 5 over x. I mean, you could leave it like this, right, but we should simplify this. So let's simplify it. What do we mean when we say simplify, though? We want to combine this. This is called a complex fraction. So let's just do that work on the side here, right? Let's add 5 over x plus 3. Okay, we can put that 3 over 1. And these fractions, we want to get the same denominator, right? So we'll put 5 over x, and we'll put 3x over x here. Okay, and that way they have the same denominator, and then we'll just combine these to get 5 plus 3x all over x. Okay, so this becomes 5 plus 3x all over x, but all of that divided by 2. Okay, and you notice that instead of dividing by 2, right, we can multiply, we can flip this over, right, times 2 over 1. Okay, so that becomes what? 10 plus 6x all over x. Notice this is f of g of x. Okay, this is f of g of x right here. So what is the domain of this function? Okay. The domain of this function, remember, the domain is asking for the possible values of x that will work in here, right? Are there any values of x that won't work? Okay. And whenever we deal with functions and domain, you always have to consider, right, denominators and radicals, right? We know that radicals cannot be negative. What do you know about denominators? We know that denominators cannot be 0, right? So let's try to do this, right? What if I said, hey, evaluate f of g of 0? And what would you say in this case? Well, this is f of g of x, so what happens when we plug 0 into this function? We're going to get a 0 in denominator, right? What does that mean? It means that f of g of 0 does not exist. So what can we conclude here? We can conclude that 0 is not in the domain. But is there any other value of x that will not be in the domain? And in this case, the answer is no, right? Because 0 is the only value of x that will cause this denominator to equal 0, right? Also, we can see that g of 0, right? Just g of 0 by itself, that does not exist either, right? Yeah, hopefully that makes sense. Okay? F of g of 0 does not exist because, well, first of all, g of 0, that doesn't even exist either. Okay? Now, we should give the answer in interval notation. So remember, the answer is going to be all real numbers except 0. Okay? So how do we exclude one value in interval notation? Okay? We just write it negative infinity up till 0, but with parentheses, right? And then union 0 to infinity, right? So this would be the domain of f of g of x in interval notation.